Before getting into example 4, we'll take a quick review of the percentages of distribution, and these have to be known. So what you must know is that within one standard deviation below is 34% of the data, and one standard deviation above is 34%. So within one standard deviation of the mean is 68% of all the data. Then, within two standard deviations, below and above will be 95%. We took our 68, subtracted from 95, we're left with 27% that has to be spread in the two pink regions. And that would leave 13.5% for each region. And then last, from 3 standard deviations back and above, we hold 99.7% of all the information. Now, how much is that for each of these areas here? Well, in total, there will be 99.7 subtract 95, or 4.7%, and when we divide that in 2, split it equally, you have 2.35% in each region. So we'll just look at that here. Now let's also remember that from the mean below is 50%. So from here below on this side is 50% of all the data, and up here in this region it's also 50% of the data, so it counts for all the scores. So we'll take this now and we'll apply it to example 4. So it says Shirley wants to buy a new cell phone. She searches the cell phone she is considering and finds the data on its longevity in years. So we're looking at, that's asking how long the phone will last. And the first question is, does the data show a normal distribution? Well, you carry out your statistics and find out the mean and standard deviation. And you'd also find the median. If you want to know if the data is normally distributed, you're going to compare the mean with the median. And what we know here, if we analyze those results, I'm not going to take time to do it right now. I mean, we can use Excel or another piece of technology or website as I've shown you in class, and you would find that the mean is 2.526, standard deviation 0.482, and the median is 2.55. So when the mean and median are close to each other, that would suggest that the data is normally distributed. So I'd say it would answer that question. Now for the last question, it's asking if Shirley purchased this cell phone, what's the likelihood that it will last more than 3 years? Well, if you just look at a sketch of the graph, of normal distribution, so our mean will be here, and if we have 1 deviation above, or 0.48 above, we will be at, for here, 3.008 years. So what we're looking for, the likelihood that it will last more than 3 years, again, that's only 1 deviation above. So if it came here, we're looking at from here, and we want 1 deviation above. So if we know our percentages, we want to know what's the chances it would last longer than 3 years. Well, it will be our 13.5 plus 2.35. 15.85, or approximately 16% chance for lasting longer than 3 years. Another way of doing that question is that we would know, and I'll just erase what I have there. We know that half our data is below the mean. So we have 50% of the data tied up here. And then we have 34% tied up in this region. Now, if you think of the graph as a whole, in total, the graph would represent all the data. But if we take away these percentages here, we would have what's remaining. So from here below is 50% of the data. From the mean below is 50% of the data. We know it's 34% in that region. So 50% there. We know there's approximately 34% there. So in total, 84% of the data is left. So if we take that away from 100, and that's looking at all cell phones, we'd be left with 16%. And that would mean that's at 16% here. Okay, the your turn question. As to Shirley purchased this cell phone, what is the likelihood it will last at least 18 months? So we want 18 months or greater. So we need to keep that in mind. 18 months or greater. First, we need to figure out where would 18 months lay on our distribution curve. So our mean, as we figured out earlier, is 2.526. Now, what I'm going to do is move back one standard deviation. So I'm going to subtract, and here's what it says: take your mean, subtract one standard deviation. So 2.526, subtract our standard deviation, 0.48, would put us at 2.4. So that's not 18 months. Remember, 18 months is 1.5 years, or 1.5 years. So now I move back another standard deviation, and here I'm hitting approximately 1.5 years. So I want to know what's the chance of a cell phone lasting at least that long. So I want here or greater. So the likelihood will be it's 100% from here up. I need to consider all these percentages. So if I think about the graph, the whole graph would account for 100% of all cell phones. If I take away the case where the cell phone wouldn't last that long, there's only a 2.35% chance that the phone would not last 18 months. So if I remove that from the situation, then I'm going to be left with the cases where it will be left that long. So approximately 97.65%, or roughly about 98% chance that the phone would last at least 18 months. So you have to keep in mind in the chart here what exactly you're looking for. So looking for at least, so we're considering all the data from here up. The data represents, or the chart should represent 100% of all cell phones. And then we're just going to move those cases where cell phone wouldn't last that long. So if we move the cases where the phone wouldn't last that long, we'd be left with times when the phone does last that long or more.